Let's try this. Okay, that's good. Let's go here. All right, so cloud service models. As well as the ownership model, public, private, hybrid, or community cloud services are often differentiated on the level of complexity and pre-configuration provided. These models are referred to as something or anything as a service. The three most common implementations are infrastructure, software, and platform. Infrastructure as a service is a means of provisioning IT resources such as servers, load balancers, and storage area network components quickly rather than purchase these components and the internet. Oh, wow. Hello. Let me just say hello real quick. All right. So rather than purchase these components and the internet links they require, you rent them on a as-needed basis with the service provider's data center. Examples are Amazon Elastic Cloud Compute or Compute Cloud, Microsoft Azure Virtual Machines, Oracle Cloud, and OpenStack. Nice. Software as a service is a different model of provisioning software applications. Rather than purchasing software licenses for a given number of seats, a business would access software hosted on a supplier's servers on a pay-as-you-go or lease arrangement on demand. Virtual infrastructure allows developers to provision on-demand applications much more quickly than previously. The applications can be developed and tested in the cloud without the need to test and deploy on client computers. Examples include Microsoft Office 365, Salesforce, and Google G Suite. Platform as a service provides resources somewhere between SaaS and IaaS. Yes. A typical PaaS solution would provide servers and storage network infrastructure as per yes, but also provide a multi-tier application database platform on top. The platform could be based on Oracle or Microsoft SQL or PHP and MySQL. Examples include Oracle Database, Microsoft Azure SQL Database, and Google App Engine. As distinct from SaaS, though, the platform would not be configured to actually do anything. Your own developer would have to create the software that runs using the platform. Service provider would be responsible for the integrity and availability of the platform components, but you would be responsible for the security of the application you created on the platform. There it is. Amazon Web Services, Elastic Compute Cloud. They really focus on that a lot in this CompTIA. Like, I love Amazon Web Services. Okay. Anything as a service. There are many other examples of XaaS. Who comes up with these acronyms? Like, seriously. Reflecting the idea that anything can be provisioned as a cloud service. For example, database as a service and network as a service can be distinguished as more specific types of platforms as a service. The key security consideration when all these models is identifying where responsibilities lie. This is often referred to as security in the cloud versus security of the cloud. Security of the cloud. Security in the cloud is the things you must take responsibility for. Security of the cloud is the things the CSP manages. These responsibilities vary according to the service type. It's based on contractual agreements. Security as a service. The breadth of technologies Acquiring specialist security knowledge and configuration makes it likely that companies will need to depend on third-party support at some point. You can classify such support in 3 general tiers. Consultants. The experience and perspective of a third-party professional can be hugely useful in improving security awareness and capabilities in any type of organization, small to large. Consultants could be used for big-picture framework analysis and alignment, or for more specific or product-focused projects, pen testing, SIEM rollout, and so on. It is also fairly simple to control costs when using consultants, if they are used to develop capabilities rather than implement them. Where consultants come to own the security function, it can be difficult to change or sever the relationship. Managed security services provider, a means of fully outsourcing responsibility for information assurance to a third party. This type of solution is expensive but can be a good fit for an SME that has experienced rapid growth and has no in-house security capability. Of course, this type of outsourcing places a huge amount of trust in the MSSP. Maintaining effective oversight of the MSSP requires a good degree of internal security awareness and expertise. There could also be significant challenges in industry exposed to high degrees of regulation in terms of information processing. Security as a service can mean lots of different things, but is typically distinguished from an MSSP as being a means of implementing a particular security control, such as virus scanning or SIEM-like functionality in the cloud. Typically, there would be a connector to the cloud service installed locally. For example, an antivirus agent would scan files locally but be managed and updated from the cloud provider. Similarly, a log collector would submit events to the cloud service for aggregation and correlation. Examples include Cloudflare, Mandiant, and FireEye and SonicWall. FireEye has been used pretty commonly as a suggestion. Virtualization technologies and hypervision types. Virtualization means that multiple operating systems can be installed and run simultaneously on a single computer. A virtual platform requires at least 3 components. So this is what we were going over with the VirtualBox. There's virtual machine as well. People use that too. So what you need is a host hardware, the platform that will host the virtual environment. Optionally, there may be multiple hosts networked together. Hypervision virtual machine monitor manages the virtual machine environment and facilitates interaction with the computer hardware network. Guest operating systems, virtual machine or instances operating systems installed under the virtual environment. One basic distinction that can be made between virtual platforms is between host and bare metal methods of interacting with the host hardware. In a guest OS or host-based system, the hypervisor application, known as Type 2 hypervisor, is itself installed onto a host operating system. Examples of host-based hypervisors include VMware Workstation, Oracle VirtualBox. That's what we use, right? We got the Oracle VirtualBox up in here. Uh-oh. Did I lose it? Ah, where's my VirtualBox? Oh, no, I misspelled that. Oh, there it is. Okay. Whew. So yeah, I'm using Oracle VirtualBox, which is the hypervisor. And the hypervisor software must support the host OS. So the hypervisor, Oracle box, then inside the Oracle box, when we click inside the Oracle box, let me get back over here. Oh gosh. Oracle VirtualBox. Let's do this. We have got, if it'll load, whoo, there it is. Okay, so inside the VirtualBox, we've got the host OS, which is Kali Linux. You can add more. You can put more on here. Okay. And this is all inside of my operating system, Windows. Okay. If that helps for visualization and conceptualizing, because maybe some people are visual learners out there. But anyways, and then that operating system is, of course, connected to my laptop, the hardware, like all that stuff. Okay. All right. I hope that helped. If not, I fail. A bare metal virtual platform means that the hypervisor type 1 hypervisor is installed directly onto the computer and manages access to the host hardware without going through a host OS. Examples include VMware, Microsoft Hyper-V, and Citrix Xen server. So my professor doesn't really like these, but it's, you know, it's up to you guys how you want to set it up. He swears by VirtualBox. The hardware needs only support the base system requirements for the hypervisor plus resources for the type and number of guest OSs that will be installed. So the virtual machine, VirtualBox is on the side with all these other OSs. Oh, wait, no. This is the virtual machine. My apologies. And there's some kind of machine manager. And then connect to the hardware. Okay, cool. Let's see what James has got to say about this.
When it comes to secure virtualization technology, some of the terms you want to think about are the OS, the hypervisor, and the guest OS. So the OS that you're going to be running on, for example, Windows, then you have some sort of hypervisor. That could be VMware. I use VirtualBox personally. And then you have the guest OS. These are the types of things that you want to think about and understand their security and how they work. Let me show you a couple of things here. I've got just a fairly typical example here of VirtualBox going. These are all of my...
See, look, even he goes by VirtualBox, okay, guys?
Virtual machines that I use on a fairly regular basis, believe it or not. Each of these is supposed to be separate, a separate instance from the other. The only way they're supposed to be able to talk to each other is through standard networking or standard communications. Or if you configure them to actually communicate with each other via, say, shared folders or drag and drop and things like that. But the idea is that you really don't want these communicating via either some sort of side channel attack or the idea of some form of communication where these two can actually leak information with each other. So it's the job of the hypervisor to make sure that only the only communication that happens is actually allowed. Now, the way that you can keep these things secure, of course, is to make sure that you have got proper updates for all of your virtualization. And so here we have it. Now, this is a typical type 2 virtualization solution. In other words, you have basically your virtual machine here, right? Then you basically have the hypervisor sitting on top of an operating system, and then the hardware. The actual PC in this case is running. Now, let me show you something that's considered really a bare metal sort of approach. And this bare metal kind of approach is something that allows you to take a look at the virtual machines that allows you to create virtual machines. In this case, actually, a virtual desktop interface. It allows you to create this, not just where you have the guest OS, the hypervisor, then the operating system, and then the hardware. It actually allows you to get started and launch something right away. And I'm going to do a quick setup here, which allows you to actually get started creating a virtual desktop environment, some sort of bare metal type situation here. And I'll just get going here with a Linux system and create my little username here. I'll call it StangerNet. Stanger here. And I'm basically creating a virtual desktop environment here that allows people to get going and actually create a workspace. And this workspace is something that can follow you from device to device. So basically, instead of saying, well, I've logged into my PC somewhere, and then I have my phone, and that's a different interface, and then another PC, this one, once you launch it, can actually go around with you and follow the user around no matter where that person goes as that person logs in. This is something that, again, is subject to the same kind of concerns in that you don't want one person's virtual desktop interface to communicate with another one out of the proper bounds, unless those two users are actually communicating with each other directly. One of the issues with having this kind of power available, whether it be the standard type 2 virtualization via VirtualBox or via Amazon Web Services or Azure, is that as these things are so available, it's kind of the democratization of IT. Most anybody can start launching these things and bring them into the workspace. We thought it was bad that USB drives came in or mobile phones with BYOD. Now you have kind of this shadow IT kind of situation that can arise with undocumented systems and system sprawl. So documentation of all of this is very important. So it's important to update it. It's important to document the systems that you have and to even document the updates that you have on the systems that you're aware of.
Yeah, so what he's talking about is like, so you got to update the Oracle box, VirtualBox, and then you can also update over here. But it would be nice if there was like an update button like right here, so you could update. But you got to go in and do it like the original way of doing it on an operating system, which is kind of a bummer, but is whatever's. So yeah. All right. It is the future. Okay, so virtual desktop infrastructure and thin clients. Virtual desktop infrastructure refers to using a VM as a means of provisioning corporate desktops. In typical VDI, desktop computers are replaced by low-spec, low-power, thin client computers. When the thin client starts, it boots minimal OS, allowing the user to log on to a VM stored on the company server infrastructure. User makes a connection to the VM using some sort of remote desktop protocol. Thin client has to find the correct image and use an appropriate authentication mechanism. Maybe a one-to-one mapping based on the machine name or IP address, or the process of finding an image may be handled by a connection broker. I've never done anything like that before. At least that I know of. I've never been to a job where they do that, but could be the way of the future. All application processing and data storage in a virtual desktop environment or workspace is performed by the server. The thin client computer must only be powerful enough to display the screen, image, play audio, and transfer mouse, key commands, video, and audio information over the network. All data is stored on the server, so it's easier to back up, and the desktop VMs are easier to support and troubleshoot. They are better locked against unsecure user practices because any changes to the VM can easily be overwritten from the template image. With VDI, it is also easier for a company to completely offload their IT infrastructure to a third-party services company. The main disadvantage is that in the event of a failure in the service and network infrastructure, users have no local processing ability, so downtime events may be even more costly in terms of lost productivity. Application virtualization and container virtualization. Application virtualization is a more limited type of VDI rather than run the whole client desktop as a virtual platform. The client either accesses an application hosted on a server or streams the application from the server to the client. For local processing, most application virtualization solutions are based on Citrix, XenApp, formerly MetaFrame Presentation Server, though Microsoft has developed an App V product with its Windows Server range, and VMware has the ThinApp product. These solution types are now often used with HTML5 remote desktop apps, referred to as clientless, because users can access them through ordinary web browser software. Application cell container virtualization dispenses with the idea of a hypervisor and instead enforces resource separation at the operating system level. The OS defines isolated cells for each user instance to run in. Each cell or container is allocated CPU and memory resources, but the processes all run through the native OS kernel. These containers may run slightly different OS distributions, but cannot run against OSes of different types. You cannot run Windows or Ubuntu in a Red Hat Linux container, for instance. Alternatively, the containers might run separate application processes, in which case the variables and libraries required by the application processes are added to the container. One of the best known container virtualization products is Docker. Containerization underpins many cloud services. In particular, it supports microservices and serverless architecture. containerization is also being widely used to implement corporate workspaces on mobile devices. Yeah, like I have not seen any of this stuff being used before, so this is all new to me. That's pretty wild, though. All right, VM escape protection. VM escaping refers to malware running on a guest OS jumping to another guest or to the host. To do this, malware must identify that it's running in a virtual environment, which is usually simple to do. One means of doing so is through a timing attack. A classic timing attack is to send multiple usernames to an authentication server and measure the server response times. An invalid username will usually be rejected very quickly, but a valid one will take longer. While the authentication server checks a password, this allows the attacker to harvest valid usernames. Malware can use a timing attack within a guest OS to detect whether it is running in a VM. Certain operations may take a distinct amount of time compared to a real environment. There are numerous other signatures that an attacker could use to detect the presence of virtualized system hardware. Next step in VM escaping is for the attacker to compromise the hypervisor. Security researchers have been focusing on this type of exploit, and several vulnerabilities have been found in popular hypervisors. One serious implication of VM escaping is where virtualization is used for hosted applications. If you have a hosted web server, apart from trusting the hosting provider with your data, you have no idea what other applications might be running in other customers' VMs. Does anybody feel like this sounds like Inception a little bit? Like it's an OS inside of an OS, and the malware is like Leonardo DiCaprio's character, where he's trying to figure out if he's in the dream or if he's in reality. That's what I'm thinking of right now. It went totally through Inception. I was just like, oh, such a good movie. Anyways, for example, consider a scenario where you have an e-commerce web server installed on a virtual server leased from an ISP. If a third party installs another guest OS with malware that can subvert the virtual server's hypervisor, they might be able to gain access to your server or to data held in the memory of the physical server. Having compromised the hypervisor, they can make a copy of your server image and download it to any location. This would allow the attacker to steal any unencrypted data held on the e-commerce server. Even worse, it could conceivably allow them to steal encrypted data by obtaining private encryption keys stored on the server, or by sniffing unencrypted data or a data encryption key from the physical server's memory. It is imperative to monitor security bulletins for the hypervisor software that you operate and to install patches and updates promptly. You should also design the VM architecture carefully so that the placement of VMs running different types of applications with different security requirements does not raise unnecessary risks. Preventing VM escaping is dependent on the virtualization vendor identifying and securing vulnerabilities in the hypervisor on these being patched. The impact of VM escaping can be reduced by using effective service design and network placement when deploying VMs. For example, when considering security zones such as DMZ, VMs provide front-end and middleware back-end services should be separated to different physical hosts, which reduces the security implications of VM escaping attack on a host in the DMZ. Oh, man. Oh, what's this? Okay. Sorry about that, guys. I was just looking at some messages. Yeah. Okay, good. All right, so we're looking at VM sprawl avoidance. As well as securing the hypervisor, you must also treat each VM as you would any other network host. This means using security policies and controls to ensure the confidentiality, integrity, and availability. CIA triad, really important to remember. Confidentiality, integrity, and availability. That's like a really big deal. It makes up the core, I guess, ethos of what cybersecurity is. Each VM needs to be installed with its own security software suite to protect against malware and intrusion attempts. Each guest must also have a patch management process. This might mean installing updates locally or replacing the guest instance from an updated VM template image. Ordinary antivirus software installed on the host will not detect viruses infecting the guest OS. Scanning the virtual disks of guest OSes from the host will cause serious performance problems. Although one of the primary benefits of virtualization is the ease of deploying new systems, this type of system sprawl and deployment of undocumented assets can also be the root of security issues. What is going on? Why is my phone blowing up so much? That is great, guys. I'm so happy for you. 1-800-Flowers was a horrible experience for me, and they still continue to harass me. I just tried it once for my wife, get some flowers, and they were hydrangeas. They showed up, they were dead within a day. They charged me I think like $100 for it. And then my wife was so mad, she called them up, and then they gave us like a 50% off, and then they gave us another thing of flowers, which that aspect was nice, but I just wasn't really happy with the first set of hydrangeas. Can't do it right once. Why should I use your services again? And they spam me with emails constantly, which is just kind of ugh, gross. So anyways, let's see. The case that will be brought, okay, although one of the primary benefits of virtualization is the ease of deploying new systems, this type of system sprawl and deployment of undocumented assets can also be the root of security issues. It will often be the case that a system will be brought up for just a minute to test something, but languish for months or years, undocumented, unsecured, and unpatched. Each of these undocumented systems could represent an exploitable vulnerability. They increase the potential attack surface of the network. Policies and procedures for tracking, securing, and when no longer used, destroying virtualized assets should be put in place and carefully enforced. Virtual machine life cycle management software can be deployed to enforce VM sprawl avoidance. VMLM solutions provide you with a centralized dashboard for maintaining and monitoring all the virtual environments in your organization. More generally, the management procedures for developing and deploying machine images need to be tightly drafted and monitored. VMs should conform to an application-specific template with the minimum configuration needed to run that application, that is, not running unnecessary services. Images should not be run in any sort of environment where they could be infected by malware or have any sort of malicious code inserted. One of the biggest concerns here is of rogue developers or contractors installing backdoors or logic bombs within a machine image. The problem of criminal or disgruntled staff is obviously one that affects any sort of security environment, but concealing code within VM machine images is a bit easier to accomplish and has the potential to be much more destructive. What's Glassdoor trying to tell me? I really need to change that. I don't know. I think, I don't know. Okay. A cloud is a bunch of servers that anybody can access. Solution hosted by a third-party cloud service provider shared between subscribers, multi-tenant, sort of cloud solution has the greatest security concerns? Kind of. What type of cloud solution would be used to implement a SAN? I don't know that one. This would usually be described as an infrastructure as a service. Yes. No, I did not get that. Type 2 hypervisor would be like VirtualBox, virtual machine, software that manages virtual machines that has been installed to a guest OS. This is in contrast to a Type 1 or bare metal hypervisor, which interfaces directly with the host hardware. Kind of. I mean, I didn't describe it like that. This is the problem I have with the note cards. The note cards are like, guess what's in my head? And I'm like, well, I think this is the direction you're going with it. And then they're like, no. So what is a VD? I don't remember that one. Virtual desktop environment. Oh, that makes sense. It's the workspace presented when accessing an instance in a virtual desktop infrastructure solution. VDI is the whole solution: host, server, and virtualization platform, connection protocols, connection, session broker, and client access devices. Did you get it right? No. Was the risk from a VM escaping attack? Well, you can have malware enter into your host system or server. VM escaping refers to attacking other guest OSes, the hypervisor or host from within a virtual machine. Attacks may be steal information, perform denial of service, infect the system with malware, and so on. Kind of? I don't know. I didn't say it quite like that, but okay. All right, we're going to apply cloud security solutions, performance-based questions. You are a systems consultant who's been hired by an organization looking for a second opinion on security settings for their new cloud implementation. Their cloud implementation is with a leading cloud provider, and the systems are in a public cloud space. The organization has provided a basic network diagram. As I understand that the network security is severely misconfigured and lacking. Your task is to compare the current security settings and make recommendations, specifically the public access. Based on best practices, you'll use this to update the diagram for internal IT documentation purposes. Organizational notes from the current IT admin. Default cloud service credentials that I use for daily management were provided to you earlier. We have a web server that accesses an application on the back end of a storage bucket. I think that's what it's called. Used for storing large video assets used by the servers. Videos are available for streaming to our client members. I wanted to create different accounts for different systems that access each other, but I couldn't figure out how. Should we use groups with roles as well? I've been told that users can log into the disk bucket directly where assets are stored. Is that possible? If so, that can't happen. I heard that using a secret key for access would be best, but I'm so over my head this project, and I don't know what that means. It's only internal users, developers should have elevated user accounts. Clients should have minimal access. All systems accounts currently belong to the same security group. Admin has not created any new security. Just want to check and make sure I didn't miss anybody here. Okay. Let's see what we got. Admin should not use default accounts. Admin has not created any new security groups. There should be 4 descriptive levels of security defined for permission types. Groups will provide the required permissions to resources. Customers can access only the front-end server. Application and storage will not use user accounts for access. Okay. All right, logical cloud architecture, company internal confidential. So for accessing the container, you don't want them, that should be like root access, user account. I would say developers. For the security group, that should be private. Yeah, no. Well, that's got to be public, I think. That one. The users are private. Let's see. Policy role. Internal subscription. No, you know what? That should be external, and that should be subscription. Let's roll with that. Management account currently uses access a user account development practice supposed to utilize a all right. The storage container which contains video assets and the back-end server which contains applications should use programmatic access. This can be done with APIs and will allow access between the systems. This type of access uses a secret key. Admin will configure the front-end server to accept logins with user accounts. Clients will use user accounts called clients. Security group. Groups will provide permissions. Both the storage container and backend server will belong to a private group. Admin will assign the front-end server to a public group and assign client users to subscription. Okay. Policy role. Policies and roles used within the group grant specific abilities. Admin will assign storage container and backend server to internal. The admin will assign the front-end server to an external policy role as its requirements differ from the other systems, specifically more public presence to the client's users. All client subscribers will use a subscriber policy. Post security review feedback. The daily management account is the default account. This is a root account, and admin should not use the root account for daily management activities. A user account could be given elevated privileges and used as needed. A secret key is used for the programmatic access. This type of access differs from a user account and used when systems integrate and authenticate to each other. Let's see, there's that. Learning plan. Okay. Apply cloud security solutions. So we're going over these objectives. Configuring cloud security solutions shares many principles and processes with on-premises security, but plenty of unfamiliar technologies and challenges too. Weak configuration of cloud services can make any attack vectors available, and the public nature of cloud means that they will quickly be discovered and exploited. You must be able to apply policies and technical controls to provision, compute, network, and storage cloud resources with attributes of confidentiality, integrity, and availability. Switching standards to say.
When using virtualized resources inside of the cloud, some of the things that you'll have to think about are ways to segment the traffic, and that's done via VPCs, via virtual private clouds. Listed some here, or at least put some in here. You can talk about availability zones, and I've listed 3 zones here. Whatever goes into those zones are the machines, as it were, or the services or the capabilities that you need. One could be storage, for example. One could be in databases, whatever you need. But the idea is that you may need to create your own private network in the cloud, and that's effectively what a VPC is. I was once talking to somebody who had not been exposed to traditional networking with servers and data centers or server rooms or whatever. And I remember it was kind of going, well, what do I need to know about network subnetting anymore? I mean, the cloud takes care of all of that. Well, actually, that's not the case. Those concepts of subnetting, of segmenting traffic, private IP addressing, all those fun things are still very much in play. You just now do them within the cloud. Because you're going to be creating for each of these availability zones, subnets effectively. So you have to know all of these things. The benefit of VPC is that it basically makes it possible for you to create public or private facing subnets. It enables you to put together these availability zones to basically isolate traffic, make sure that you've got a little bit of security in place. It sets the foundation for finding ways to share workload, etc. So you can set up regions for these things and put together kind of also alternatives where traffic can go. When it comes to VPCs, there are a few concepts you'll want to understand. First of all, you will be working with private IP addressing and subnets. Second of all, there's an isolation of workload that goes on. The idea that you have public-facing networks, you'll have an internet gateway in that case, and private, where you don't use a public IP address. So at a professional level, you'll need to understand those concepts, regardless if you're talking about Google Cloud or IBM's Cloud or AWS or Azure. You'll be enabling availability zones and things of that nature. Just a few ideas. The other concepts, of course, are you'll be talking about endpoints. They'll be internal and private is what they are. And you'll be talking about gateways that connect to storage and databases, and there are interfaces that are for very private services. So there's the gateway versus interface is something to think about. In this particular graphic, I've listed a couple of options. If you have one VPC, we'll call it a VPC-A, and there's VPC-B. You can peer them together, but usually they're done via a transit gateway. A lot of different ways to connect these two different things. You can do it via standard peering, but generally the transit gateway is something that is the most interesting. It's a way of managing traffic more logically and efficiently between one VPC and the other, or one VPC and many others. And it's effectively a virtual router that handles traffic. Additional things that you'll be setting up, of course, will be network address translation. And you'll also be setting up network access control lists. And this means you'll be understanding, the services available and the ports and the source and destination. All of these things, fairly traditional concepts, but just they found a new venue in the cloud. The other thing that you'll be talking about are the concept of security groups. That's a very universal phrase, and it's part of segmenting traffic. It's effectively where you're creating a virtual firewall. And a couple of examples here of what it means to create a security group. In fact, I took a screenshot from when I was doing that the other day, doing some independent work. Here's a couple of URLs you can look at to see a perspective, at least a couple of vendors' perspectives of how to implement security groups. But the idea is, once again, you can create effectively firewalls to segment things. When it comes to putting together permissions in the cloud, a lot of folks will use the term bucket and bucket permissions. Let me take a step back and talk about the idea of a bucket. I suppose it's a good metaphor, because if the cloud involves rain and then you have buckets, but the rain falls into buckets. But the idea of bucket permission is that a bucket is a container that holds data or holds some form of service. So if you want to store something, use something in the cloud, it needs to be contained. It is contained in a bucket. And so you can assign very granular permissions or universal permissions to each bucket. It's effectively something to understand it. So in some ways, it's kind of like a group policy in Windows, or a group policy you can find in a Kerberos domain in Linux. This code here that you're looking at is basically one vendor's way of saying, here's how, from a programming perspective, a programmer's perspective, you can actually start applying permissions across each bucket. So the idea is that you define a resource, an object. And so as you set up access to objects, you can set read and write permissions to that particular bucket. And after you identify those permissions, the next thing that you'll be doing is determining kind of what will go into that particular access control list. And so you can see I've got StangerNet 1, and I've got storage 1 and streaming 1 here in stangernet.com, where I basically put together some possibility of where I could actually start assigning bucket permissions. Firewall appliances are also interesting in regards to this, because you could either have a virtual appliance set up through your cloud provider, or you may have one on premise that then works with the cloud provider. It'll intercept packets, it'll inspect them, and processes them based on whatever layer you want to talk about. Layer 3, traditional packet filter; layer 7, application filters, things like that. And there are additional layers of the OSIRM, layer 4, that you could be talking about doing proxy work. But the idea is that you can put things in place, and each of these firewalls will have effectively templates that you'd be using. And these templates are basically ready-made firewall rules, sets of rules that you can then take and edit. They do a lot of the work for you, but you're still going to need to know a lot of those elements, whether you call them traditional elements of firewalls or understanding how ports and protocols work in the TCP/IP suite. You're going to need to know those things as you work to basically manage traffic in the cloud. When it comes to VPCs, I've put together a short little demo here. The idea is that as you work with resources by a particular region, you can set up VPCs. And notice that you're going to have to start configuring subnets. There's routing tables, internet gateways. Sound all familiar to anybody who's been in the industry for very long? You have peering connections. You can also set up gateways. And the idea is that you can set all of these things up, and you can, of course, follow a particular wizard if you want to go in and setting this up. But you can see, if you don't know your subnetting, you're going to be lost even if you go in and use the wizard. So the fundamentals always apply when it comes to networking, regardless if you're doing it in the cloud or whatever vendor. They're not going to be able to make it easy for you unless you have those that proper foundation of networking, understanding of networks.
All right. I am going to I'll be right back, guys. I need to get some more water. Sorry, guys. Let's see what we got going on. Okay. So, going into cloud security integration and auditing. Cloud-based services must be integrated within regular security policies and procedures and audited for compliance. Where indicators of on-premises attacks are found in local application logs and network traffic, indicators of cloud-based attacks are found in API logs and metrics. The same correlation to suspicious IP address ranges and domains and suspicious code strings must be made. But the source of this data is the cloud service provider. Accessing this auditing information in real time may be difficult depending on the cloud service type. There are many cloud-based SIEM solutions that can perform this collection, aggregation, and correlation of security data from both on-premises and cloud-based networks and instances. As with any contracted service, cloud computing is a means of transferring risk. As such, it is imperative to identify precisely which risks you are transferring. So I think this really reflects well with how the government wants to go to cloud-based systems. If you want to go to cloud-based systems and you put confidential, restricted data, top secret data, you're going to basically give another company responsibility of all that information, which can be data mined, which can be used for nefarious purposes, and or if something else that is associated with your cloud is done for nefarious purposes, it could be taken by the government. I mean, the government taking government stuff, you know, it's not like that's never happened before. Anyways, the whole idea is that maybe you might want to think about cloud before doing that stuff because there is a lot of risk. To identify which responsibilities a service provider is undertaking and to identify which responsibilities remain with you. This should be set out in a service level agreement with a responsibility matrix. For example, in a SaaS solution, the provider may be responsible for the confidentiality, integrity, and availability of the software. They would be responsible for configuring a fault-tolerant clustered server service for firewalling the servers and creating proper authentication, authorization, and accounting procedures for scanning for intrusions and monitoring network logs, applying Operate OS and software patches, and so on. You might or might not be responsible for some or all of the software management functions, though ensuring the administrators and user practice good password management, configuring system privileges, and making backups of data, and so on. Where critical tasks are the responsibility of the service provider, you should try to ensure that there is a reporting mechanism to show that these tasks are being completed, that their disaster recovery plans are effective, and so on. Another condition is that your company is likely to still be directly liable for serious security breaches. If customer data is stolen, for instance, or if your hosted website is hacked and used to distribute malware, you still have liability for legal and regulatory requirements. That sucks. You might be able to sue the service provider for damages, but your company would still be the point of investigation. You may also need to consider the legal implications of using a cloud provider if its servers are located in a different country. Yeah. If you put your information on a cloud server in China, that's such a bad move. China has access to all your information. The government, they don't care. I don't know if you guys have been looking at Google or some of those other bigwig companies that are working in China, but China has access to their information, their data, and it's for militarization purposes. So yeah, there's certain countries you do not want to work in because they will take all your crap and use it. Also, I don't know if you guys know about China recently sending, well, this isn't recent, it was a while ago, but sending people into Micron. It was actually IMFT at the time. Intel Micron had a merger, and they sent Chinese spies, essentially, to put USBs into random systems and steal data. So that's one of the things that I was there for the aftermath of that, and security got super tight. Literally couldn't do my job. Got frustrated with it. Said, all right, well, if you guys don't want me to update your embedded systems, then it's just like, I don't need to work here. But yeah, it's been a big problem recently. Big enough of a problem that they went to the president of the United States to say, hey, can you guys do something about this? So we need to also consider the risk of insider threat, where the insiders and administrators are working for the service provider. So Amazon Workspaces has a disgruntled employee or something, and without effective security mechanisms such as separation of duties and a quorum authentication, it is highly likely that they would be able to gain privileged access to your data. Consequently, the service provider must be able to demonstrate to your satisfaction that they are prevented from doing so. There's also the risk described earlier that your data is in proximity to other unknown virtual servers and that some sort of attack could be launched on your data from another virtual server, which I think that's where the side loading stuff comes in, where they attack the server and then try to go to another server on the same network. So oh, I didn't hear about this Twitter hack. Let's see. Twitter hack affecting high-profile accounts being hijacked for a Bitcoin scam is a good illustration for the risks from insider threat. As with any contracted service, with any AAS solution, you place a large amount of trust in the service provider. The more important the service is to your business, the more risk you are investing in that trust relationship. Cloud security controls. Clouds use the same type of security controls as on-premises networks, including identifying access management, endpoint protection for virtual instances, resource policies to govern access to data and services, firewalls to filter traffic between hosts, and logging to provide an audit function. Most CSPs will provide these security controls as native functionality of the cloud platform. Google's firewall service is an example of this type of cloud native control. The controls can be deployed and configured using either the CSP's web console or programmatically via command line interface or application program interface. A third-party solution would typically be installed as a virtual instance within the cloud. For example, you might prefer to run a third-party network next generation firewall. This can be configured as an appliance and deployed to the cloud, the virtual network. Architecture can be defined so that this appliance instance is able to inspect traffic and apply policies to it, either by routing the traffic through the instance or by using some type of bridging or mirroring. As an example, consider the configuration guide for the Barracuda next-gen firewall. The same considerations can be made for other types of security controls, notably data loss, prevention, and compliance management. Cloud-native controls might not exist for these use cases. They might not meet the functional requirements that third-party solutions can, and they may be too steep a transition in terms of change management and skills development. Application security and IAM. Application security in the cloud refers both to the software development process and to identify and access management features designed to ensure authorized use of applications. Just as with on-premises solutions, cloud-based IAM enables the creation of user and user security groups plus role-based management of privileges. Secrets management. A cloud service is highly vulnerable to remote access. A failure of credential management is likely to be exploited by malicious actors. You must enforce strong authentication policy to mitigate risk. Do not use the root user for the CSP account for any day-to-day login activity. Require strong multi-factor authentication for interactive logons. Use conditional authentication to deny or warn of risk account activity. Principles, user accounts, security groups, roles, and services can interact with cloud services via CLIs and APIs. Such programmatic access is enabled by accessing a secret key to the account. Only the secret key, not the ordinary account credentials, can be accessed. Used for programmatic access. When a secret key is generated for an account, it must be immediately transferred to the host and keep securely on that host. Cloud compute security. Cloud provides resources abstracted from physical hardware via one or more layers of virtualization. The compute component provides process and system memory resource as required for a particular workload. The workload could be a virtual machine instance configured with 4 CPUs and 16 gigabyte RAM, or it could be a container instance spun up to perform a function and return a result within a given time frame. The virtualization layer ensures that the resources required for this task are made available on demand. This can be referred to as a dynamic resource allocation. It will be the responsibility of the CSPs to ensure this capability is met to the standards agreed in the SLA. Within the compute component, the following critical security considerations can be identified. Container security. A container uses many shared components on the underlying platform, meaning it must be carefully configured to reduce the risk of data exposure in a container engine such as Docker. Each container is isolated from others through separate namespaces and control groups. Namespaces prevent one container reading or writing processes in another, while control groups ensure that no one container cannot overwhelm others in a DOS-type attack. API inspection and integration. API is the means by which consumers interact with cloud infrastructure, platform, or application. The consumer may use direct API calls or may use a CSP-supplied web console as a graphical interface for the API. Monitoring API usage gives warning if the system is becoming overloaded and allows detection of unauthorized usage or attempted usage. Number of requests. This basic load metric counts numbers of requests per second or requests per minute. Depending on the service type, you might be able to establish baselines for typical usage and set thresholds for alerting abnormal usage. And an unexplained spike in API calls could be an indicator of a DDoS attack. For instance, latency. This is the time in milliseconds taken for the service to respond to an API call. This can be measured for specific services or as an aggregate value across all services. High latency usually means that compute resources are insufficient. The cause of this could be genuine load or DDoS. However, error rates, this measures the number of errors as a percentage of total calls, usually classifying error types under category headings. Errors may represent an overloaded system if the API is unresponsive, or a security issue if the errors are authorization access denied types. Unauthorized and suspicious endpoints. Connections to the API can be managed in the same sort of way as remote access. The client endpoint initiating the connection can be restricted using an ACL, and the endpoint IP address monitored for geographic location. Instance awareness. As with on-premises virtualization, it is important to manage instances, virtual machines, and containers to avoid sprawl where undocumented instances are launched and left unmanaged, as well as restricting rights to launch instances. You should configure logging and monitoring to track usage. Cloud storage security. Where the compute component refers to CPU and system memory resources, the storage component means the provisioning of persistent storage capacity. As with the compute component, the cloud virtualization layer abstracts the underlying hardware to provide the required storage type, such as a virtual disk for a VM instance. object-based storage to serve static files in a web application, or block storage for use by a database server. Storage profiles will have different performance characteristics for different applications, such as fast SSD backed storage for databases versus slower HDD backed media for archiving. The principal performance metric is the number of input-output operations per second supported. Permissions and resource policies. As with on-premises systems, cloud storage resources must be configured to allow reads and/or writes only from authorized endpoints in the cloud. A resource policy acts as the ACL for an object. In a resource policy, permissions statements are typically written as the JavaScript object notation strings. Misconfiguration of these resource policies is a widely exploited attack vector. For example, the following policy uses the any wildcard to assign both actions read and write principals accounts to a storage object. This type of policy breaks the principle of least privilege and is highly unsecure. I love wildcard though. It's great. That's how I find stuff. Encryption. Cloud storage encryption equates to the on-premises concept of full disk encryption. The purpose is to minimize the risk of data loss via an insider or intruder attack on the CSP storage systems. Each storage unit is encrypted using an AES key. If an attacker were to physically access a data center and copy or remove a disk, the data on the disk would not be readable. To read or write the data, the AES key must be available to the VM or container using the storage object. With CSP managed keys, the cloud provider handles this process by using the access control rights configured on the storage resource to determine whether access is approved, and if so, making the key available to the VM or container. The key will be stored in a hardware security module within the cloud. The hardware security module and separation of duties policies protect the keys from insider threat. Alternatively, customers can manage keys themselves, taking on all responsibility for secure distribution and storage. Encryption can also be applied at other levels. For example, applications can selectively encrypt file system objects or use database level encryption to encrypt fields and/or records. All networking, whether customer to cloud or between VMs, containers within the cloud, should use encrypted protocols such as HTTPS or IPsec. Got to have that HTTPS, man. You guys are going to websites that don't have HTTPS, you're putting yourself at risk. It's really easy to hack. All right. High availability. One of the benefits of the cloud is the potential for providing services that are resilient to failures at different levels, such as component, server, local network, site, data center, and wide area network. The CSP uses a virtualization layer to ensure that compute, storage, and network provision meet the availability criteria set out in its SLA. In terms of storage performance tiers, high availability refers to storage provision with a guarantee of 99.99% uptime or better. As with on-premises architecture, the CSP uses redundancy to make multiple disk controllers and storage devices available to a pool of storage resource. Data may be replicated between pools or groups, with each pool supported by separate hardware resources. Replication. Uh-oh. When it gets to replication, it gets terrifying. You know those replicating robots? Data replication allows businesses to copy data to where it can be utilized most effectively. The cloud may be used as a central storage area, making data available among all business units. Data replication requires low latency network connections, security, and data integrity. CSPs offer several data storage performance tiers. Terms hot and cold storage refer to how quickly data is retrieved. Hot storage retrieves data more quickly than cold, but the quicker the data retrieval, the higher the cost, of course. Different applications have diverse replication requirements. A database generally needs low latency, synchronous replication, as a transaction often cannot be considered complete until it has been made on all replicas. A mechanism to replicate data files to backup storage might not have such high requirements depending on the criticality of the data. High availability across zones. CSPs divide the world into regions. Each region is independent of the others. Autobots roll out. Autobots roll out. Let's see. Availability zones have independent data centers with their own power, cooling, and network connectivity. You can choose to host data services and VM instances in a particular region to provide a lower latency to customers. Provisioning resources in multiple zones and regions can also improve performance and increases redundancy, but requires an adequate level of replication performance. Consequently, CSPs offer several tiers of replication representing different high availability service levels. There's local replication, replicate your data within a single data center in the region where you created your storage account. The replicas are often in separate fault domains and upgrade domains. Regional replication, also called zone redundant storage, replicates your data across multiple data centers within 1 or 2 regions. This safeguards data and access in the event a single data center is destroyed or goes offline. Geo-redundant storage replicates your data to a secondary region that is distant from the primary region. This safeguards data in the event of a regional outage or a disaster, like Texas getting flooded and all the servers getting zapped, or Texas losing its power, or Texas. I'll just stop. Cloud networking security. Within the cloud, the CSP establishes a virtualization layer that abstracts the underlying physical network. This allows the CSP to operate a public cloud where the networking performed by each customer account is isolated from the others. In terms of customer configured and cloud networking, there are various contexts. Networks by which the cloud consumer operates and manages the cloud systems. Virtual networks established between VMs and containers within the cloud. Virtual networks by which cloud services are published to guests and or customers on the internet. Virtual private clouds. Each customer can create one or more virtual private cloud attached to their account. By default, a VPC, virtual private cloud, is associated with other CSP accounts and from other VPCs operating in the same account. This means that a customer A cannot view traffic passing over customer B's virtual private cloud. The workload for each virtual private cloud is associated with, is isolated from other VPCs. Within the VPC, the cloud consumer, words. Can assign an IPv CIDR block and configure one or more subnets within the block. Optionally, an IPv6 CIDR block can be assigned also. The following notes focus on features and networks in AWS. Other vendors support similar functionality, though sometimes with different terminology. For example, in Microsoft Azure, VPCs are referred to as virtual networks. Public and private subnets. Each subnet within a VPC can either be private or public. To configure a public subnet, first, an Internet Gateway virtual router must be attached to the VPC configuration. Secondly, the Internet Gateway must be configured as the default route for each public subnet. If a default route is not configured, the subnet remains private, even if an Internet Gateway is attached to the VPC. Each instance in the subnet must also be configured with a public IP in its cloud profile. The Internet Gateway performs one-to-one network address translation to route Internet communications to and from the instance. The instance network adapter is not configured with this public IP address. The instance's NIC is configured with an IP address for the subnet. The public address is used by the virtualization management layer only. Public IP addresses can be assigned from your own pool or from a CSP managed service such as Amazon's Elastic IP. There are other ways to provision external connectivity for a subnet if it is not appropriate to make it public. NAT Gateway, this feature allows an instance to connect out to the internet or to other AWS services, but does not allow connections initiated from the internet. VPN. There are various options for establishing connections to and between VPCs using virtual private networks at the software layer or using CSP managed features. Oh, did I learn anything? Did I get my learning goal? Oh. Let me see where I'm at on my lessons. Did I skip any of these? Look at that. Oh, I did. There we go. Continue. Go back to my lessons here. I've still got so much more to go. Some of these, though, topics are just... What's the longest section? Echo. That 14 might be the longest section, then. It did feel like it went on forever. All right. Cloud firewall security. Cloud firewall security. As in an on-premises network, a firewall determines whether to accept or to deny, discard incoming, outgoing traffic. Firewalls work with multiple accounts, VPCs, subnets within VPCs, and instances within subnets to enforce the segmentation required by the architectural design. Segmentation may be needed for many different reasons, including separating workloads for performance and load balancing, keeping data processing within an isolated segment for compliance with laws and regulations, and compartmentalizing data access and processing for different departments or functional requirements. Filtering decisions can be made based on packet headers and payload contents at various layers identified in terms of the OSI model. So network layer 3, layer 3. This is all OSI. We need to know this for sure. Network layer 3. The firewall accepts or denies connections on the basis of IP addresses or address ranges and TCP UDP port numbers. The latter are actually contained in layer 4 headers, but the functionality is still always described as basic layer 3 packet filtering. Transport layer, layer 4. The net firewall can store connection states and use rules to allow established or related traffic. Because the firewall must maintain a state table of existing connections, this requires more processing power, CPU, and memory. Application layer, layer 7. The firewall can parse application protocol headers and payloads such as HTTP packets and make filtering decisions based on their contents. This requires even greater processing capacity or load balancing, or the firewall will become a bottleneck and increase network latency. While you can use cloud-based firewalls to implement on-premises network security, here we are primarily concerned with the use of firewalls to filter traffic within and to and from the cloud itself. Such firewalls can be implemented in several ways to suit different purposes. As software running on an instance, this sort of host-based firewall is identical to ones that you would configure for an on-premises home. It could be a stateful packet filtering firewall or a web application firewall with a rule set tuned to preventing malicious attacks. The drawback is that the software consumes instance resources and so is not very efficient. Also, managing the rule sets across many instances can be challenging. As a service at the virtualization layer to filter traffic between VPC subnets and instances, this equates to the concept of an on-premises network firewall. Native cloud application-aware firewalls incur transaction costs, typically calculated on time deployed and traffic volume. These costs might be a reason to choose a third-party solution instead of the native control. Well, alrighty then. Security groups. In AWS, basic packet filtering rules managing traffic that each instance will accept can be managed through security groups. A security group provides stateful inbound and outbound filtering at layer 4. The stateful filtering properties means that it will allow established and related traffic if a new connection has been accepted. The default security group allows an outbound traffic and any inbound traffic from instances also bound to the default security group. A custom security group sets the ports and endpoints that are allowed for inbound and outbound traffic. There are no deny rules for security groups. For any traffic that does not match an allow rule is dropped. Consequently, a custom group with no rules will drop all network traffic. Multiple instances can be assigned to the same security group, and instances within the same subnet can be assigned to different security groups. You can also assign multiple security groups to the same instance. You can also assign security groups to VPC endpoint interfaces. Configure your security group. Oh, they blotted out their IP address right there. Most cloud providers support similar filtering functionality, though they may be implemented differently. For example, in Azure, network security groups can be applied to network interfaces or to subnets. Hooray. Click. Cloud Access Security Brokers. A cloud access security broker is enterprise management software designed to mediate access to cloud services by users across all types of devices. Cloud access security broker vendors include Bluecoat, Bluecoat, now owned by Symantec, Sky High Networks, now owned by McAfee, ForcePoint, Microsoft Cloud App Security, and Cisco CloudLock. Cloud access security brokers provide you with visibility into how clients and other network nodes are using cloud services. Some of the functions of a cloud access security broker are: enable single sign-on authentication and enforce access controls and authorizations from the enterprise network to the cloud provider. Scan for malware and rogue or non-compliant device access. Monitor and audit user and resource activity. Mitigate data exfiltration by preventing access to unauthorized cloud services from managed devices. In general, cloud access security brokers are implemented in one of the three following ways. Forward proxy. This is a security appliance or host positioned at the client network edge that forwards user traffic to the cloud network if the contents of that traffic comply with policy. This requires configuration of users' devices or installation of an agent. In this mode, the proxy can inspect all traffic in real time, even if that traffic is not bound for sanctioned cloud applications. The problem with this mode is that users may be able to evade the proxy and connect directly. Proxies are also associated with poor performance, as without a load balancing solution, they become a bottleneck and potentially a single point of failure. Gross. Does not sound good. Reverse proxy. This is positioned at the cloud network edge and directs traffic to cloud services if the contents of that traffic comply with policy. This does not require configuration of a user's device. The approach is only possible if the cloud application has proxy support. Application programming interface. Rather than placing a CASB appliance or host inline with cloud consumers and the cloud services and API-based CASB broker connections between the cloud service and the cloud consumer. For example, if a user account has been disabled or an authorization has been revoked on the local network, the CASB would communicate this to the cloud service and use its API to disable access thereto. This depends on the API supporting the range of functions that the CASB and access and authorization policies demand. CASB solutions are quite likely to use both proxy and API models for different security management purposes. Next generation secure web gateway. Enterprise networks often make use of secure web gateways. An on-premises secure web gateway is a proxy-based firewall, content filter, and intrusion detection prevention system that mediates user access to internet sites and services. A next generation secure web gateway, as marketed by Netscope, combines the functionality of an secure web gateway with that of data loss prevention and a cloud access security broker to provide a wholly cloud-hosted platform for client access to websites and cloud apps. This supports an architecture defined by Gartner as Secure Access Service Edge. Boom. Look at that. Go points, go. All right. So just so you guys know, I will be transitioning to certified ethical hacker. There you go. So here, lab, access my labs. Click it there. Do this. Do some of this. Do some of this. Some of that. All right, so we're doing malware threats still. Last time we were scanning and debugging malware viruses and all that good jazz. I need to go take a break real quick while this loads someday. I'll be back. I'll be back. All right, guys. Unfortunately, something did pop up. I will have to go do that, and then I will be back later today. Have a good day. Bye.